Here in 7.7, we're going to be taking a look at solving radical equations. Really just one objective, solving equations containing radicals. What you want to remember is what is our goal in solving equations. Anytime we have an equation, whether it's a linear or with its absolute value, or now with radical, we're trying to isolate the variable that's identified in the problem and figuring out what its value is, one of the values. Whenever you see an equation with a radical that has a variable in the radicand, this is called a radical equation. And that will definitely separate a radical equation from just a normal linear equation. Because if the variable is on the outside of a radical, that's simply a linear equation. Where if the variable is inside the radical, that would be considered a radical equation. So we solved this one simply by dividing by the square root of 2. You may have to rationalize or something, but we get x by itself that way. To get x by itself on this one, we have to peel off or rip off the square root sign. We have to use the inverse to do that, and we'll talk about that as we go through. The process of solving radical equations is really a 5-step sort of process. Step number 1 is isolate the radical containing the variable. It's a lot like when we said isolating absolute values. You want to get the radical by itself. If there's something on the outside of the radical, let's say you had something like square root of x plus 3 equals 7. Well, we want to get this is what we're trying to get by itself, so we can get the x by itself. So the first thing we always have to do is move any constants or coefficients that are outside the radical, move those opposite the radical so that we can get that radical by itself, simply by, in this case, subtracting 3. And so that's what we're talking about here, is isolating a specific radical with a variable inside. So move constants by addition and subtraction, move coefficients by multiplication. So, real basic example real quickly here is if you had the 2 square roots of x plus 3 equals 7, what we want to do first is this is what we're trying to isolate right there. And so we want to get that by itself. So we need to undo constants first by subtracting 3. So you get 2 square roots of x equals 4. Then divide by 2 because we want to get that radical by itself. And now we can proceed with solving for x through the rest of these steps that we have for this. So really step 2 is, okay, once you get that radical isolated, how do we get rid of the radical sign? Because remember what we're trying to do is get inside the radical to the variable that's inside. And so we want to undo the radical. Hopefully what you remember about undo is inverse. Now, we've talked about that quite a bit, is that the inverse and undo are synonyms with each other. So if we want to undo or peel apart this radical, we need to use the inverse of square rooting something. The inverse of square rooting something is squaring something. Okay, those are inverse operations. We're going to use exponents to cancel out radicals. Okay? So square roots will go with squares, and maybe we'll have a cube root once in a while. Well, we'll want to cube a cube root in order to peel off that radical to get to the variable. Whatever you have to do to one side, what you need to remember, though, is whatever you do to one side of the equation, you have to do the other, right? Now, this is important because once we square one side, the left side of the equation, we're going to have to end up squaring the right side of the equation, or cube the left side of the equation, we have to cube the right side of the equation. And so whatever you do to one side, you got to do the other. That's pretty common when we talk about equations, keeping it balanced. Step number 3 is we need to isolate the variable. Once the radical has been removed, we need to get the variable by itself. So there may be more things inside the radical than what we want. So we may undo this radical by squaring both sides, and so that would cancel the radical, but I still need to move that plus 1. That's still in the way of my variable, and so I'll need to move it eventually. Okay, and then what we need to do on step number 4 is really repeat steps 1 and 2 if a radical still remains. Those are going to be some more of the advanced ones right here on number 4, but you will encounter those on your homework. And so I want to make sure to show you at least an example or two of those harder ones. You must check your answer. You don't have really a choice. It's not me saying it. It's really the math saying it, because there are extraneous solutions out there that we need to be careful of. And remember, the extraneous solutions are solutions that you haven't done anything wrong as a student, but the problem just doesn't work. It gives you an undefined value, or in our case, a lot of times, it'll give you an imaginary value, plugging it back in. It just doesn't work. So make sure to check your answers when you're done. But those are the steps. Isolate the radical containing the variable, undo the radical using exponents, isolate the variable, repeat step 1 and 2 if there's a radical that still remains, and then you must check your solution for those extraneous solutions. Okay, moving on to some examples. If you take a look here, we're going to look at some square roots to start with. Step number one, the first thing we have to do is what we're trying to do is get x by itself. X is inside of this radical. So we're trying to get x by itself. To get that, we have to get the radical by itself so we can peel off the radical sign. So step number one is we need to isolate the radical, get the radical by itself. So we'll go ahead and subtract 2 from both sides. At that point, to undo a radical, what we need to do is we need to use the inverse of square rooting something, which is squaring it. These are now peeled off or ripped off, and so what we have now is x plus 1 equals 4. The square root and the squares undo each other, they're inverses, so therefore we just have x plus 1, and we go ahead and solve by subtracting 1, and we get 3. Now we do need to check this answer, even though I circled it. If I plug the 3 back in, I get the square root of 3 plus 1 plus 2 equals 4. So I get the square root of 4 plus 2 equals 4. Square root of 4 is 2. 2 plus 2. Hey, we're in the right spot here. 4 equals 4. That's a true statement. I know I have the right answer. The answer is 3. Take a look at this problem right here. Same exact one. It's actually easier than the one we just did because we don't have to isolate anything. The radical that has the variable inside of it is already isolated. This is what we're trying to get by itself. So I need to go ahead and peel off the square root or undo the square root. What is the opposite of square rooting something? Squaring it. Very good. So we just go ahead and square both sides. Notice that I'm squaring both sides of the equation. These undo. 4x plus 1 equals 9. Subtract your 1. And then divide by 4. And this one works out to be 2. Make sure to check your answer. We plug it back in. We get 8 plus 1 inside of the square root equals 3. The square root of 9 equals 3. Sure it does. That's a true statement. So I know it works. So I know that 2 is going to be my answer. A lot of your problems are going to be similar to these, where the square roots that you're going to need to get and undo. And moving on, taking a look at just some conversions using a rational exponents. That's what we did in 7-6, right? A lot of practice there. No difference. And some of you may just want to go ahead and convert this to a radical. Notice the square root, this 1/2 exponent means square root. So if I rewrote it, it would look like this. And so some of you may prefer to rewrite it using a radical. And so go for it. I mean, if that's what you're comfortable with, go ahead and do it. We need to get this radical by itself. Now, you can do this 2 ways. You can either add the square root of 7 minus y, and that leaves 4 over on the left side, or you can subtract 4, but then you have to get rid of that negative. So really doesn't matter which path you take. I'm going to go ahead and add my square root. I like keeping that positive. So I get to here. Now we need to undo it. How do we undo a square root? We square it, and we get 16 equals these undo. And so you're 7 minus y. Go ahead and solve for y. We subtract 7. Oh, I don't want the opposite of y. I want y. So y is negative 9. Before I move on, I've got to check it. So I plug negative 9. Either one of these two are fine. But if I plug negative 9 in, I get the square root of 16, which is 4. 4 minus 4 is 0. Bam. There it is. Negative 9 is my solution to this radical equation. Still moving on. We take a look at some more advanced ones. This is where we have double radicals, a radical on each side. Now, sometimes you kill 2 birds with 1 stone, like on this problem. Sometimes you don't when we get to a later one. This one, you have them on both sides. We can kill 2 birds with 1 stone. So I'll look at the third type in just a moment. But if we go ahead, this one over here, we're going to look at an extraneous one. So that's why it has a star and a no solution. But let's look at this one right here. I want to get this variable by itself. I know there's a variable over here. But let's just pick one radical at a time. So that radical I want to get isolated, which it already is. How do I undo a square root? I square it. Whatever you do to one side, you do the other. Well, look, isn't this just precious? I mean, it just cancels each other out. Both sides. That just works out really nicely. Now I can go ahead and combine my x's. I subtract x from both sides and add 7. And we get 9 as an answer. Definitely checking your answers when there's double radicals. That's where you get a lot of extraneous solutions. So we plug it in. I get 18 minus 7 is 11. So I get the square root of 11. I'm not sure what that is. It's in between 3 and 4. But I know it's the square root of 11. If I plug in 9 over here, then what I get is I get the square root of 11. Well, those two match up. And so therefore, 9 is my solution. Let's take a look at the one over here to the far right. This one is labeled no solution. Let's see why. Because it looks very similar to the one we had to the left, which we got a solution. So we want to isolate a specific radical, which this one's already isolated, so let's undo it. And that's by squaring both sides. Again, we've sort of killed 2 birds with 1 stone on this specific problem. And so we get to this point, I subtract x and I add 4. And notice what we get is negative 1 equals x, so I get an answer. Nothing seems wrong here. But when I plug negative 1 back in, notice what happens. Uh-oh. Negative 1 minus 5 is the square root of negative 6. That's an issue. Isn't that complex? That's an imaginary solution. Even if I plug this in over here and get the square root of negative 6, as soon as you get an imaginary solution, you're talking no real solution in this case. So negative 1 is not a solution. This would actually be a no solution, or the null sign, because it's not real. And we're only talking real solutions when we talk about these radical equations. Okay, so you on occasion will have some that will have an extraneous solution. Again, this one is your extraneous solution. Now let's take a look at one more sort of challenging one that we dealt with this here. So I'm going to erase this screen and get you one more and then move on to the last ones here. Last one we want to take a look at, we'll have double radicals, but we're not going to be able to get rid of them both at the same time. And so what we have is we have one that looks like this, and then over on this side we have something that looks like that. Now, we need to isolate one radical at a time. So let's just pick this one, and the reason is it's already isolated. So I chose that one. I need to get to the variable. So to get to the variable, I got to peel off the square root. In other words, undo the square root. How do we undo a square root? We square it. Whatever you do to one side, you got to do the other side. Not to each term, but the entire side. Now this is huge because this right here is an expansion. If you remember, we cannot take an exponent across a plus or minus sign, or you owe me snickerdoodle, so we got to expand this over here. This side just becomes x minus 15. So let's look at what happens to the right side here now that I expanded. This right side, I go ahead and FOIL. So I got first, outer, inner, and last. Now last is a negative times a negative, which is positive. Square root of x times square root of x is x. So I did a FOIL here to expand this out. Notice I still have radicals. Let's go ahead and simplify this a little bit. I have 9 minus 6 square root of x plus x. And over here I have x minus 15. Let's go ahead, because what I need to do now is notice I have a radical still left. This is repeating the steps now. If you have a radical still left, you need to repeat the steps by isolating the radical and undoing the radical. So we need to go ahead and move all this stuff over here. Notice the x cancel. I subtract the 9, I get negative 24. I have negative 6 square roots of x, divide by negative 6. I'm not there yet. Now I'm ready. Now I'm ready to undo the radical. I square both sides, and I get 16 equals x. I get an answer. Does it work? Let's plug it in. 16 minus 15 is 1. Square root of 1 is 1. So left side's 1. Square root of 16 is 4. 3 minus 4, negative 1. Is that the same? No, it isn't. 16 is not a solution. This is actually a no solution as well. It's an extraneous. So notice this one. This is very complicated. This would be the highest level of type that you're going to have. But notice this use of expansion over here on these two. Notice how to do that, because that's going to be key for you, is expanding that out. Okay? And then isolating the remaining radical by moving everything else to the other side. Now, once you do that, you can check your answer to make sure that is not extraneous. In this case, it was. Okay? Let's go ahead and take a look at these last couple of problems. These are roots other than square root. This isn't too bad, actually. If you got the square root down, you're fine. The process isn't any different. We got to get the radical by itself. So again, this is a cube root, and the cube root is actually isolated. Once it's isolated, I got to peel off the cube root. How do you undo a cube root? What's the inverse of cube rooting something? Cubing it. Whatever you do to one side, you've got to do the other. So we cube both sides. This cancels. You're left with x minus 1. 2 cubes, not 6. Be careful. It's 2 times 2 times 2. It's 8. Add your 1, and you get 9. Awesome. Let's check our answer. 9 minus 1 is 8. The cube root of 8 is 2. Does 2 equal 2? Sure it does. And so I know that's my answer right there. Taking a look at this last one right here, it's not much different. The difference is I got to go ahead and rewrite this as a cube root, and I got to get it isolated. So the 3 is not inside. It's outside the cube root. So it's going to be written like this, and then you get 5n minus 1. Minus 2 equals 0. Now if you remember the process, sort of how do we solve these? What we need to do is we need to go ahead and isolate the radical. So I need to move the constant first through addition. Then I need to go ahead and move this coefficient through division. So it looks like this. Now I divide by 3. Oh, it's a fraction. Don't panic. Not a big deal. So what we have is we have a cube root of 5n minus 1 equals 2/3. How do I undo a cube root? Well, we use the inverse. We cube it. Cube it. 5n minus 1. Now, over here, as power of a quotient, we share and we cube the 2, which is 8. We cube the 3, which is 27. Now it's just getting the variable by itself. Add the 1, common denominators. 1 is the same thing as 27 over 27. I get 5n equals 35 over 27. Dividing by 5 is the same thing as multiplying by 1/5. And so now what I have is I can cancel the 5 and that one and the 35. So I get 7 over 27. And hopefully that works out. Let's check it real quick and we'll be done. If I plug in 7 over 27, what I get is I get 35 over 27 minus 27 over 27. That's what's inside that cube root. So notice what I get is I get 8 over 27. What's the cube root of 8? 2. What's the cube root of 27? 3. So I have 3 times 2/3 minus 2. Cancel 2 minus 2, 0. It works. Amazing. Okay. Now I know I went through that very quickly for you, but hopefully you have an idea of really what linear equation or radical equations are all about. Is again, go through your process. If you go all the way back to the beginning, it's isolating a radical, okay, undoing a radical, isolating the variable. If there's still a radical, then you want to repeat steps 1 and 2, and then make sure to check your answers for extraneous solutions. We'll see you in class tomorrow.